The mth term of an arithmetic progression is n and nth term is m. Find the rth term. So we have been given mth term of an arithmetic progression, that is n, and nth term is m. So using these two information, we have to find the rth term. Okay, the general term or nth term of any arithmetic, the formula to find the general term or nth term of any arithmetic progression is a1 positive. So here nth term means we have to subtract 1 from n, that is n negative 1 times d. So this is the formula to find nth term of an arithmetic progression. That is here a1 stands for the first term and d stands for the common difference. Okay, if I want to find the rth term, then n has to be replaced by r. Then I'll be getting ar equals to a1 positive. So here we have to plug in r for n, then I'll be getting r negative 1 times d. So to get the rth term, I must be knowing the value of the first term a1 and the common difference d. So once I know the values of for the first term a1 and common difference d, I can plug in those two values over here. I can find the rth term. So using the given two information, that is mth term is n and nth term is m, I have to find the value of the first term and the common difference. Okay, let's do that process. So here we have mth term, that is am equals to n, and the nth term an equals to m. Okay, already we know the formula to find a particular term of an arithmetic progression. So here I need to write the expression which is equivalent to am. So that is a1 first term positive. Here we have m. So m negative 1 times d equals to n. So the same thing I have to do for an. Then I'll be getting a1 positive n negative 1 times d equals to m. So this is equation number 1 and this is equation number 2. So here in these two equations, I have the two unknowns, n1, a1, the first term, and d common difference. So I have to solve for these two unknowns, a1 and d. By solving these two, by solving these two equations, I have to get the values of the first term a1 and the common difference d. So here the a1 is having a coefficient 1 in the first equation, and a1 is having the same coefficient 1 in the second equation. If I subtract these two equations, I'll be able to eliminate a1 and I can solve for d. So I do equation number 1 minus equation number 2. That is, I'm subtracting second equation from the first equation. So here I have the first equation. So I'm writing the first equation, a1 positive m negative 1 times d equals to n. I write the first equation as it is. Here I have a negative sign before the second equation. So I multiply the second equation on both sides of the second equation by negative sign. Then I'll be getting negative a1 negative n negative 1 times d equals to negative m. Okay, now so when I combine these two equations, a positive a1 negative a1 will cancel out here, and I have to write this one as it is, that is m negative 1 times d, and we have negative sign over here, negative n minus 1 times d equals to n negative m. Okay, here my aim is to solve for d because we have eliminated a1. So to solve for d, what we can do is just look at the expression we have over here. We have two terms, both the terms contain d. So we can factor d out from the expression on the left side. So if I factor d out, what will I get? What do I have left in the first term and what do I have left in the second term? So for that, I have to divide both the first term and second term by the one I factor out, that is d. If I divide the first term by d, this d will cancel it. I'll be getting m negative 1. Okay, now, so d is factored. So after d is factored, what do I have left in the second term? So just divide this one by d. This d will cancel out. I have negative of n negative 1 left in the second term. 1 second. Equals to n negative m. So now we can simplify this. So we get d times. So here we have m negative 1. We can remove the first parenthesis simply. Now, before removing the second parenthesis, we have to distribute this negative sign to this n and negative 1. Then it will become negative 1, negative n, positive 1 equals to n negative m. So negative 1, positive 1 will cancel out. So d times I get m negative n equals to n negative m. So my aim is to solve for d. So I divide both sides by m negative n. So this m negative n will cancel out. I get d equals to, so here n negative m over m negative n. So if I get the same m negative n in numerator, I'll be able to simplify. So that is, I have m negative n in denominator. I need to have the same m negative n in numerator also. If I want to get m negative n in numerator, this m negative m has to become positive m, and this negative n, this positive n has to become negative n. So to make this negative m as positive m, to make this positive n as a negative n, I have to factor negative sign out. If I factor negative sign out, this n will become negative n, and this negative m will become positive m over m negative n. So d equals to negative of, so we can rewrite this expression as m negative n over m negative n. So this m negative n will cancel out. I get d equals to negative 1. Okay, now I got the common difference d, that is negative 1. So I have to plug in d is equal to 1, either into the first equation or the second equation to solve for a1. So once I get the value of a1, I can plug in the values of a1 and d into the formula for the rth term, and I can get the rth term. Okay, now what I'm going to do is I'm going to plug in d is equal to 1 into the first equation. Okay, let me continue on the next page. So a1 positive, m negative 1 times d equals to, on the right side we have n. Okay, a1 positive, we can write this d in front of m negative 1, then it will be d times m negative 1 equals to n. a1 positive, we know the value of d, that is negative 1 times m negative 1 equals to n. a1 positive times negative will become negative, and 1 times m negative 1 is m negative 1 equals to n. Okay, now we can distribute this negative sign to this one and this one. I'll be getting a1 negative m, negative times negative will become positive 1 equals to n. Okay, now to solve for a1, I have to get rid of all the values around the variable, around the unknown a1. So to get rid of this negative m, I'm adding m to both sides. And to get rid of this positive one, I subtract 1 from both sides. So this one will cancel out. I get a1 equals to, so instead of writing, here we have n positive m, but we can write as m positive n negative 1. Okay, now I got the value of the first term. So that is a1 is equal to m positive n negative 1. Okay, our target is to find the rth term. So already I have given you the formula for the nth term, but using the formula of nth term, we can write the formula for rth term, that is ar is equal to the first term a1 positive. Here we have r, so we have to subtract 1 from r, then I get r negative 1 times d. So ar equals to, now for a1, we can plug in m positive n negative 1 positive r negative 1 times the value of d is negative 1. So ar equals to m positive n negative 1. So we can multiply this negative 1 by this positive sign. We can multiply this negative sign by this positive sign, it will be, or otherwise, so if you are getting confused on this step, better you can write this negative 1 in front of the r minus 1. So we get negative 1 times r negative 1. So ar equals to m positive n negative 1. Positive times negative will be negative. 1 times r minus 1 will be r minus 1. So ar equals to m positive n negative 1. You can distribute the negative sign to this one. It will be negative r. Negative times negative will become positive 1. So positive 1, negative 1 will cancel out. So finally, ar equals to m positive n negative r. So now I got the rth term of the given arithmetic progression, that is ar is equal to m positive n negative r.